I've kept up the results from our last video where we worked out the 6 trig functions of a 30-degree angle, or a pi over 6 angle, or 60-degree angle, which is pi over 3 in radians. I've just added to our table, I want to work with a 45-degree angle, which is pi over 4 in radians. And that is something that you should be either have accidentally memorized or be working at accidentally memorizing by deriving that once a day. Okay, so this is the other acute angle where we should be able to get exact values of the 6 trig ratios without using technology. Okay, and that's because if one of the acute angles in my right triangle is 45, so is the other one, and so I've got an isosceles right triangle. So the two legs are going to be exactly the same length. So if these two angles are the same, these two sides, the two sides opposite them, are also the same. Now I can choose to make this as big or as small as I want. I like to choose easy numbers to work with, so I usually just choose to make the legs be 1. Okay. That means I'm going to need to solve for my hypotenuse, which I will call h, and we'll use the Pythagorean Theorem. So 1 squared plus 1 squared equals h squared. 1 plus 1 is h squared. 2 is h squared. Algebraically, I've got two answers. H would be plus or minus root 2. This was a geometry problem, so h is a side length. It's positive, and it's root 2. Okay, now I've got 3 sides. H, of course, is the hypotenuse. I can view either of these as being the adjacent or the opposite, because this side is opposite that 45, but adjacent to this one. I'm going to just use that as my angle and label the sides that way. So then this one would be the one that's opposite, and this one would be adjacent. Okay, excellent. So if I go to look at sine of theta, or sine of 45 degrees, or sine of pi over 4, which is the same thing, okay? That's going to be opposite over hypotenuse, so that's 1 over root 2. Of course, I can rationalize that, so I'll multiply by 1 in the form of root 2 over root 2, and I get root 2 over 2. When I look at cosine, I get exactly the same thing. I now get adjacent over hypotenuse is 1 over root 2, but I've just done the work to rationalize that. That's the same as root 2 over 2. So sine and cosine are the same for a 45-degree angle. That makes sense because the opposite adjacent sides are the same. Okay. Tangent would be opposite over adjacent. That's 1 over 1. And of course, we just write that as 1. Cosecant is the reciprocal of sine. If I go back to the original, which was 1 over root 2, if I flip that, I just get root 2 over 1, and I can just write that as root 2. If sine and cosine were the same, their reciprocals are the same. So secant, which is the reciprocal of cosine, is also root 2, and cotangent is the reciprocal of tangent. The reciprocal of 1 is 1. So I've got all of those values, and all of that information is encoded in these two triangles. The 45, 45, 90 triangle gives me the information for a 45-degree angle, which in radians would be pi over 4, and the 30, 60, 90 triangle gives me all the information for both 30 degrees and 60 degrees, again in radians, pi over 6 and pi over 3.